Yes. So hello my dear students. So I welcome you to NEET World. So this is our third day we are discussing bridge course, right? So today in this session we will be doing the mole concept and also stoichiometric calculations. Okay. So now in the last class we have discussed about the what exactly mole, like fundamental understanding of mole, right? Then next we have compared from the basic terms like what exactly mean by pair, the next dozen, the next gross, then we move to the mole, right? Then next we have discussed about molar mass also. What exactly molar mass? It is a mass of 1 mole of any substance. Okay. So now if I take 1 mole of carbon, so 1 mole of carbon I am taking, 1 mole of carbon I am taking. So what is the mass of this 1 mole of carbon atoms? So 1 mole of carbon atoms will be having 12 grams. So this is how we have understood in the last class also, right? So next if I take 1 mole of nitrogen, if they say nitrogen, that's it. So you should understand that N2 gas it is. Okay, what is the standard state of nitrogen? Diatomic form, like gaseous state it will be. So you should understand like that. Okay. So then next, okay, just a minute, whether everything is audible or not. Yes. Yeah. So now what I am saying, 1 mole of N2. So it means what is its mass? 14. 14 is for nitrogen atom. So it is a molecule now. So 14 into 2 times. So it will be 28 grams. These things, the basic things we have discussed in the last class. So what is the units for molar mass? Molar mass. It means mass. It means grams. Mole, gram per mole is a unit for this molar mass. Okay. So if someone asks you what is the molar mass of carbon, should say 12 gram per mole. Okay. Nitrogen 28 gram per mole. Nitrogen atom, nitrogen atom, it is 14 gram per mole, like that. Okay. Then next, here some conversion. Yesterday we have discussed a few conversions also. Conversions means what? So for example, they are giving something in terms of weight. Okay. Now they are asking how many moles it is, number of moles if it is asked. By giving weight they are asking number of moles. So how can we do this? Yesterday we have seen now example, let us say I have 14 grams of nitrogen gas. Okay. So given 14 grams of nitrogen gas, then express number of moles. How many number of moles it is? How can we do this? Given weight by number of moles. Yesterday we have derived this formula. So number of moles of N2 equals to, how can we find? Weight of N2 by molar mass of N2. So what is the weight given? 14. What is its 14 grams? Okay, molar mass is how much for N2? Just now we discussed 28 gram per mole. Okay, so it will be 1 by 2, so 1 by 2 mole, so I can write 0.5 mole. Hope it is clear how we are solving this kind of questions, na? Simple only, na? Okay. Now I am giving you one question, take it as a homework question. So how many moles of oxygen in 320 grams of oxygen, 320 grams of oxygen. So it's a very basic question. So you can try this, just give a try. Very simple, very easy question. Yes. Then next, so what are the conversions? Just now we have discussed, if the given mass is given, so we can divide it with molar mass, so that we will get number of moles. Okay. So given mass by molar mass gives number of moles. Okay. Then next, So to convert given number of moles into number of atoms or number of entities into moles. So this is one more method. So first method is clear. Yesterday also we discussed. I have given few questions also on finding number of moles if they give mass, right? So in this class let us understand if number of atoms is given, how can we find it number of moles? Okay, so let us take one example. For example, here we know 1 mole of any substance. If we take 1 mole of any substance, how many particles it will be having? How many particles? 1 mole of any substance contains Avogadro number of particles. So Avogadro number is how much? 6.0. See, 1 mole of a substance is given. It means Avogadro number of that substance particles will be there. Okay, so 1 mole of carbon I have given. It means it contains Avogadro number of carbon atoms. Okay, so Na, which is mean by Avogadro number, which is equals to 6.022 10 power 23 atoms, like that. Okay, now I am giving you 1 mole carbon dioxide. Okay, so now tell me how many carbon dioxide molecules will be there in the given 1 mole of CO2? Very easy now. So tell me first. 1 mole CO2 I have given. So what do you understand from this 1 mole word? So it contains Avogadro number 6.022 into 10 power 23 CO2 molecules. What it contains? CO2 molecules. If I ask you in 1 mole of carbon dioxide, how many carbon atoms are present? Yes, tell me, how many carbon atoms are present here? See, in 1 CO2, how many carbon atoms are there? In 1 molecule of CO2. See, 1 molecule of CO2 contains 1 carbon atom now. It means 1 mole of CO2 contains 1 mole of carbon atoms. That means Avogadro number of carbon atoms. Okay, it contains 1 mole of carbon atoms. Okay, so it means we can write 6.022 into 10 power 23 carbon atoms. Is this clear? Very basic thing. And one more thing I just wanted to add here. I am adding. How many moles of oxygen atoms are there here? Yes, in 1 molecule of CO2, we have 1 carbon atom, 2 oxygen atoms. It is in 1 molecule. If I say 1 mole, so in 1 molecule 2 oxygen atom, in 1 mole into 2. So 2 moles of oxygen atoms. So it means 2 into Avogadro number. So 2 into 6.022 into 10 power 23. Right? So this big number, this 6.022 into 10 power 23, we just simply represent it as Avogadro number Na. So now the question is total number of atoms if they ask. How can we do this? So total number of atoms. See, in 1 molecule of CO2, how many atoms are there total? 1 carbon plus 2 oxygen. So 3 atoms. So total how many atoms? In 1 molecule contains 3 atoms. Okay? So in 1 mole CO2 contains how many atoms? 3 into Avogadro. 3 Na. Is that clear? This is a basic understanding. So just write it in your notes. This is clear now? Now let us understand little more about this formula and its applications. Okay. Now I am giving you I am giving you 3.011 into 10 power 23 carbon atoms. 3.011 into 10 power 23 carbon atom. Express it in terms of number of moles and weight of carbon in grams. How can we do this? So what I have given, number of carbon atoms I have given. I am asking you to find number of moles. N represents number of moles. Weight, WT represents weight. Okay, tell me that. How can we do this? Yes, very easy. First, whatever the number they have given, relate it to the Avogadro number. What I am saying? So it means we know they are asking about number of moles now. We know 1 mole means how many carbon atoms? 6.022 into 10 power 23 carbon atoms. How many atoms given here? Given, how many given? 3.011 into 10 power 23. See, if 6.022 into 10 power 23 is there, means that we are saying it as 1 mole. If this number is given, see in the question they have given this number, it means how many moles it is? X, let us say. Yes, so we need to find this X. So just interlink this, so that what is the difference between these two? By doing by 2 we will get this number. So here also X will become, by doing by 2 we will get X equals to half. So we can use here something called unitary method. So what is this unitary method means? So just multiply this X, this is what we need to find now, X into this number. So 6.022 into 10 power 23 into X equals to this number into this number, 3.011 into 10 power 23. So we can find X now. So you just send this number here, X equals to 3.011 into 10 power 23 by 6.022 into 10 power 23. So this 10 power 23 cancel, this 2 times. Okay, so how many moles we got? 1 by 2 mole. Okay, so why I have given this many steps? Directly I can write here, but you need to know how you can take the steps, each step, and most of you are NEET students. Okay, so might be facing difficulties while simplification. So this is how you can understand the things. Okay, is that clear? Yes, you can make the note. I will be giving few more questions here. So now what you need to understand here, in order to find number of moles, we got a formula here. So what we are finding, what is X here? X representing what? It is representing number of moles here in this question. So we have found that, so number of moles equals to what we got? We have divided this with one number. What is this number called? So just write Avogadro number, okay, in the denominator. And what we need to write in the numerator? Given number of atoms. Given number of atoms given. That's it. What we will get? We will get a number of moles. I hope it is clear. Yes or no? Yes. Make this formula. So once after completing the every chapter, from now onwards itself, so from the beginning itself, you need to make your own lecture, class notes. Once after a teacher completes his class, you need to make your notes. For every chapter there will be one short note book, short note paper. Within 1 or 2 pages, it should be completely written. All the important formulas, important statements should be written in that notes. Done? Yes. Let us discuss few more things. Now tell me, number of moles in 28 grams of nitrogen atoms. Yes. Find this fast. Very simple. Dear online students, those who are in live, so try to answer these questions. You can interact with us. So I will be looking in the chat box only. So you can write in the chat box, so that the comment box. So I will be reading that, can guide you accordingly. Even if it is wrong answer, no issues, just give a try. So number of moles of N2 in nitrogen, 28 grams of nitrogen atom. They mentioned atom. Okay. So number of moles, how can we calculate? N equals to given weight 28 grams by nitrogen atom now. So means what I should take in the denominator. So what is the formula? Given weight by molar mass. Mm means molar mass. What is the molar mass of nitrogen atom? So molar mass of nitrogen atom you can write. Should not get confused between atom and molecule. Complete answer will be gone wrong if you take like that. Okay, now will tell me this 28 grams by how much I should take in the denominator. So it is atom now, so it means 14 grams you should take. Yes, 14 grams only. It is atom they mentioned. If they mention directly nitrogen, that means it is molecule. 28 you should take in that case, molar mass. Here they mention atom means you should take 14 grams only, gram per mole. Hope it is clear, there is no confusion. So you will get answer as 2 mole. Clear now? If the same question if they ask like this, number of moles in 28 grams of nitrogen. So this is different again. What makes the difference here? They mentioned atom here, they just mentioned nitrogen. It means it is diatomic molecule. So here the what happens here, what is the difference it makes? So it will be 28 grams, given weight is 28 grams only. What is its molar mass? 28. So here it is 14, here it is 28 gram per mole. So what makes the difference? It's a molecule, it's an atom. The difference you should understand, basic thing. Okay, so here you will get different answer from the above. 1 mole you will get. Okay, now tell me answer for this. The mass of 2 mole of nitrogen atom is, yes, very simple, 2 moles they mentioned. What is the formula? Number of moles. First write the formula, substitute in that. When you are at the beginning, at the initial stage of learning, do not go blindly without having proper understanding. Just start from the very basic. Write the formula. What is the formula we have? Number of moles equals to given weight by molar mass of that particular atom or element. Okay. So now how many moles they given? 2. What they are asking us? Mass they are asking. It means this one they are asking, na? In order to find this, see, if we send this side, what happens? N into molar mass equals to weight. This is what we will getting. That is what we required now. Yeah. Now tell me how many moles is given? N value 2. Molar mass how much? For atom it is 14. So weight will be 28. This is our answer. So we have option number 4. Clear now? Clear or not? So first question 2, second question 4. Yes, tell me for this. Yes, very easy question. Number of moles in 12.044 into 10 power 23. Number of nitrogen atoms. Yes, very easy. 1 mole nitrogen means? 6. Right. Here this many number of atoms is given. So what we need to take? Given number of atoms by 6. Avogadro number gives number of moles. Yes. So what is the basic formula? Directly you can use a formula, or if you want you can use that unitary method also, you will get the same answer. Okay. So what we can write here? So number of moles equals to given number of atoms they mentioned by Avogadro number. Avogadro number is 6.022 into 10 power 23. Number of atoms how many they mentioned? 12.044 into 10 power 23. So this 2 times. So how many moles we got? 2 moles. So your answer is 2 moles. 2 moles is your answer. Okay. Now if they ask weight, they are asking for nitrogen atom now. So number of moles we got. For this question we got the answer. Now I have one more question. I am asking its weight. 28 or 48. Should not get confused between these two. What they are asking? Atoms. So this number of moles of nitrogen atoms are there. So it means what we will get? 48 or 28? Once again. See, number of moles we have 2 now. So number of moles we can write weight by its molar mass equals to 2 I am writing. N means we can write like this. So I want weight. So 2 into molar mass. So what is the molar mass of nitrogen atom?
14.
That's it. It means 2 into 14. So it will be 28. Not 56 or 48 or something like that. Clear now? Should not get confused. You should be very strong with your basic understanding every time. Okay? Next. Yeah. See, making mole concept very strong is very important when you are preparing for physical chemistry part. Okay? Now tell me, even in organic and inorganic also they interlink this mole concept topics. Okay? So it is not about how much weightage this topic in the exam, it is about understanding complete physical chemistry depends on this mole concept only. Okay? Now tell me. Yes, easy question again. So just I wanted to tell you one more thing, just follow the class for few more minutes. So at the end I will be giving you one some simple trick, how can you identify, how can you interlink one another, just for some time you just completely understand the topics first. Tell me answer for this, how many atoms of nitrogen, oxygen atoms, there in 16 grams. Yes, tell me, easy again. Always remember, first of all try to find number of moles, okay, then convert it into whatever the question they are asking. They are asking about number of atoms now. First number of moles you tell me. 16 grams is given. Oxygen, what is its standard state? It is in O2 form now. So what we should take? In the denominator, 16 or 32? Given weight by molar mass. What is the molar mass of O2? 32 gram per mole. 32 gram per mole. So we got 2 times. So 2 mole we got. Right? So 2 mole, 1 by 2 mole we got. 1 by 2 mole we got. So number of moles is 1 by 2. So now if we have 1 mole, we are saying Avogadro number. If we have 1 mole, we are saying Avogadro number. But how many we have here? 1 by 2 mole. It means I can say 1 by 2 moles of NaO2 molecules. This is molecule. What they are asking? They are asking molecules are atoms. In one molecule, how many atoms are there? 2. So it means in one molecule 2 atoms are there, na? So we should multiply with this number into 2. So number of atoms, always remember number of atoms equals to number of moles into its atomicity. What do we mean by atomicity? Yesterday we discussed, na? Atomicity represents here this number. What is that atomicity number? 2 for oxygen. How many moles we got? 1 by 2 into Avogadro number. Number of moles into N into atomicity into Avogadro number. So these two get cancelled. So finally we are remaining with Na. Na means what? 6.022 into 10 power 23. Hope it is also clear now. Any confusion is there here? No. Let's move further. writing. Still you want to do it? Okay. You can write, find this. How many molecules of water present in 9 grams? Very, very easy and important question. Try to understand both of these questions. Yes. Yes, find it. How many molecules of water present in 9 grams of water? Again, what we need to find? First of all, always find, yes, find number of moles. Given weight is how much? 9 grams. Okay. What is its molar mass of water? Molar mass of water, H2O na. So for oxygen it is 16, for hydrogen it is 2 into 1, so total it is 18. So you can say 18 gram per mole. Okay. 1 by 2. So N equals to 1 by 2 mole we got, right? What I am asking, how many molecules of water present? So we have half mole now, so half into Avogadro number. Avogadro number is how much? 23. So we will get this 3.011 into 10 power 23 is our answer. Hope it is clear now. In 9 grams, how many water molecules are present? 3.0. Yeah. So if they give 9 grams of water and they will ask you how many water molecules are present, it will be 3.011 into 10 power 23. Simply you can say half Na, like half into mole now, half Na you can say, Avogadro number, Na means. If I give, instead of giving 9 grams, if I give you 3 grams, 3 by 18 into Na. 3 by 18 means 3 ones are 3, 6 are 1 by 6 into Na. Avogadro number. That's what your answer. Hope it is clear now? Yeah. So now calculate actual mass of water molecule in grams. Yes. It means 18 grams is a weight for 1 mole of water. I am asking you not for 1 mole, I want it for 1 molecule. So this is 1 mole means how many water molecules it is? This is the 18 grams is the weight for this many number of water molecules, 6.022 into 10 power 23 water molecules. Water molecules weight is this much. Yes or no? So now H2O molecules. This is 18 grams is the weight for this many water molecules. But what they are asking, actual mass of 1 water molecule, of a water molecule. It means I want it for 1. So it means I can send this side now. So what happens it is, so 18 grams is the weight for 6.022 into 10 power 23 H2O molecules, but I want for 1 H2O. So it means it is x grams. So I need to find this value of x. So it means how can I take x equals to multiply this cross multiplication, that is what unitary method I told you now. So x into 6.022 into 10 power 23 equals to 18 grams into 1. Okay. So x will be 18 by 23 like this. So this is the weight you can see. So by simplifying this, by considering this as the 6 nearest number integer, so we will get around 3 times, 6 3s are 18. So x which is nothing but weight, x is nothing but weight of H2O molecule equals to x is nothing but 3 into 10 power minus 23 grams you should say. Why I am writing minus? It is in the denominator now. So we can write in the numerator as 10 power minus 23. In the denominator is 10 power 23. If you want to write in the numerator, it is become minus. Hope it is clear? Yeah. Answer is clear now? Yeah. You can write this. Yeah. So one more thing here, when you are solving any physical chemistry questions, even in the physics or in the chemistry part, whenever you are doing some numericals, once after listening to the teacher, do not copy paste in your notes directly, just try to understand. So just try to give on your own. In your book you can write on your own, wherever you are feeling difficult or wherever you got stuck, there you can see on the board. That is what you can do. But while teacher is teaching you something, just follow him, try to understand it clearly. Okay. So try to be in the present. Okay, always try to be in the present. Okay, one more thing here. Now we have taken number of moles. Okay, we have calculated number of moles using weight. Okay, and also we can now what we can get now, we can get weight from number of moles or number of moles from weight. We can do this interconversion from here to here and here to here. And one more thing also we have did, number of atoms, right? If we know number of moles, we can find number of atoms, or if we know number of atoms, we can find number of moles. These two things we have studied till now, right? So now tell me, how can we convert number of moles into atoms? Weight, number of moles is given, multiplied with its molar mass, then it will give us weight. If weight is given and number of moles is asking, just divide it with the molar mass, that's it. Hope this small chart will be helpful. Okay, at the final we will conclude like this. Just now have a idea here. Now number of moles is given and they are asking to find number of atoms. So what we should do? Multiply with Avogadro number. If number of atoms is given, number of moles is asking, so divide it with the Avogadro number, that's it. Very basic, okay, and easy, important one again. Okay, I am erasing this. Let us move and we will understand little more things. Okay, erasing. Here see, if volume of gas is given along with its temperature, okay, if volume of gas is given, V is given and temperature is also given and pressure also given as P, then how can we find number of moles? So we have something called ideal gas equation. What is that ideal gas equation? PV equals to nRT. This is what we know. So how do we got this equation? By using gas laws. What are the gas laws we have? Boyle's law, Charles' law, Gay-Lussac's law, all these are Avogadro's law, all these are called gas laws. By summing up, by considering all together, we will get this equation, right? PV equals to nRT. So now I want to find this n value, it means number of moles. So what I can do? N equals to PV by RT. I want n only. So here P means pressure, they may give some value, you can put here. Volume also they mention, you can write here. R means universal gas constant, it will be having different values. Like in joules we can write it as 8.314, R equals to 8.314 joule, Kelvin inverse, mole inverse we can write. And in terms of calories, we can write 2 calorie per Kelvin, 2 calorie per Kelvin per mole, like this. Okay, like this we have different values. Okay. Now in terms of liter ATM, yes, we have in this term 0.082 liter ATM Kelvin inverse, mole inverse we have. Okay, hope it is clear. Now one thing you need to remember here, see, there is something called Avogadro's hypothesis, I will explain that. So 1 mole of, from that Avogadro's hypothesis, what he is saying is 1 mole of any gas at STP, NTP, okay, here NTP it is mentioned, sometimes STP also, standard temperature pressure also they will mention. So it means it is 0 Kelvin, 0 degrees and 1 bar pressure. So 1 mole of any gas occupies how much volume? It is 22.7 liters. So 1 mole of any gas, it occupies how much volume? 22.7 liters at 0 degrees and 1 bar pressure. So temperature is constant, pressure is also constant. So when temperature and pressure is constant, any gas you can take, what is the volume it is occupied? If I take 1 mole of any gas, that will be occupying 22.7 liter at 1 bar. If I take 0 degrees, this is also temperature constant, 0 degrees, temperature is constant again, and here 1 atm pressure, 1 bar and 1 atm are different now, there is little variation, right? So now here 1 mole of any gas, again here also 1 mole of any gas will occupy 22.4 liters. These are constant values, I mean experimentally founded data here. See, just by changing little pressure, the value also got changed here, right? Yeah. So let us discuss little more about the other things. Okay. Now what is the Avogadro's hypothesis I told you? So equal volumes of all gases have equal number of molecules. So it means V is directly proportional to N. So if I take this, once again read, equal volumes of all gases have equal number of molecules, okay, not atoms, okay, only molecules, like let's consider at same temperature and pressure. So what is the condition here they mentioned? Temperature and pressure should be, T and P should be constant, these should be constant. If these two are constant, V is directly proportional to K. It means, for example, 1 mole of any gas I can take, it will be having same volume. For example, I am taking 1 mole of O2, okay, at this condition, temperature and pressure. So I am saying it has some X number of oxygen molecules, X number of oxygen molecules. Now again I am taking 1 mole of H2 gas molecules, H2 gas, 1 mole of H2. So at same temperature and pressure. Now how many gas molecules it has? How many it has? It is also having X only. Why X? That is what the definition says now. 1 mole, like equal volumes of all gases contains equal number of molecules at identical temperature and pressure. If temperature pressure is same, then any gas you can take, if they are equal in volume, they will contain equal number of gas molecules. Hope it is clear? Yeah. So now that is what, so from this only we got the final explanation like this. So it is found that, here it is found that, where is that question? Here we have now, so 1 mole of gas at STP is found to be experimentally equal to 22.4 liters, which is known as molar volume. So now we got one more relation now, number of moles if they ask you, okay, by giving number of moles, if they ask volume of gas, at what condition? At STP or NTP they will be saying, okay, STP or NTP, like that they will be saying. So what we need to do? So we know 1 mole, like number of moles is given, they are asking us to find volume of gas. So just you need to multiply this with 22.4 liters. Why we need to multiply with that number? For example, what we know, 1 mole of gas means 1 mole of any substance, 1 mole of gas. How much volume it occupies? It 22.4 liters. This is at standard temperature and pressure. At this condition only, if temperature pressure changes, that will be having different volume. Yeah, so it means STP, it means 0 degrees and 1 atm pressure only this condition is applied. If it is 0 degrees and 1 bar pressure, again 22.7. Okay, if I taking other than these two values, the value, this volume also changes, it will become some other value. Hope it is clear. Okay, it depends completely on temperature and pressure values. If these values changes, the volume of that gas also changes. Okay, now let us see one question here. Look here, 5.6 liter of gas at STP weighs this much. It can be possibly which gas? Yes, in order to understand or in order to solve this question, let us take one easy question first, then later we will go for this. Okay, I am giving you 8 grams of methane at STP. Now tell me volume Tell me volume occupied by volume of methane is how much? Volume occupied by methane at this condition, tell me. So how can we do this again? Yes, first of all find the number of moles. Number of moles equals to given weight, how much? 8 grams. What is its molar mass? For methane, carbon is 12, hydrogen 4 into 1, 16 it is, right? So 16 gram per mole, okay? So it will be again 1 by 2 mole, okay? So we know 1 mole of any gas occupies how much value? Volume. 1 mole of any gas occupies 22.4 liters. So here we have half mole. It means let us consider this as X. So X by using unitary method 22.4 liter divided by 2. How we got this 2? Into 1 by 2 we should write. I mean this one into this one. We will get this like this. So it is 11.2 liters. Clear now? Okay. Now write one question. Everyone, dear online students, you can also take the question and try to solve this question, and you can write in the comment box if you know the answer. Okay, 5.6 liters of O2, 5.26 liters of oxygen is given, 5.6 liter of O2 gas is given at STP. Then what is the weight of O2 is, what is this, what is the weight of its O2, what is its weight? 5.6 liters of O2 is given now, what is its weight I am asking, tell me. This is at STP. Yeah, tell me anyone? Yeah, so how can we do this? Volume is given now. What we need to do? Yes, always remember to find number of moles. So we know 1 mole means how many? 1 mole means 22.4 liters. So they are asking, they have given 5.6 liters. So X moles you can consider. So X gives, X means let us say this is N moles, NO2. So we need to get this value of NO2. So I can write, I can generate a formula now, number of moles N equals to, what we got, just see here, number of moles equals to this one into this one and this one into this one, which are equal, right? Okay, number of moles equals to, so this one into this one and this one into this one, here I can write 5.6 now. So it means I am making a formula, given volume at STP by molar volume. So how we got this formula, tell me? So given volume is how much? Given volume is how much? Molar volume is how much? It means volume of 1 mole of substance, 22.4. This one only now we are getting here, NO2 means, yeah. So now liter got cancelled. So this will be 1 by 4. So how many moles we got? 1 by 4 mole. Okay. So we got, finally we got one more relation here. Okay. Number of moles equals to given volume by its molar volume. Okay, so here we will getting half mole, 1 by 4 mole now, 1 by 4 mole. So 1 mole means 1 mole O2 means 32 grams, 1 by 4 mole means 32 by 4 means 8 grams. So 5.6 liters of O2 at STP will be having how much weight? 8 grams. Hope it is clear? Yeah. So now here I have brought two questions for you, and I will be telling you one question and other one is for you. See here they have given same 5.6 liters of gas is given at STP. It is having this much weight. Okay, it can be possibly which gas? So 5.6 liters means how many moles it is? So what is the formula I told you? When volume is given, how can we find number of moles? Given volume by number of moles equals to given volume by molar volume. That is what you can take here. Given volume how much? 5.6. This is at STP only now, that's why I am using this formula. What? Given volume by molar volume. Molar volume how much? 22.4 liters. So this will becomes 1 by 4. How many moles we got? 1 by 4 moles of that gas, whatever the gas it is. Okay, that is what we need to find now. Okay, now number of moles we got. So now the given weight is given now. So from this weight I am writing weight by molar mass I am writing. This is a formula I am writing. Okay, so now what I am going to do here, see I am going to find molar mass. If we get a molar mass number, some number we will get now. So that number suits for which of this option? It means what is the molar mass of ammonia? So it is for nitrogen 14 and 3 hydrogens are the 3 into 1, that will be 17. For carbon 12, for oxygen 16, so it will be 8 28. For this it is 32, and for this 12 24 plus 6 30. Like this we got this molar masses now. So whatever we are finding this molar mass, it will be equals to any of this number, that will be our answer. Right now? Now how can I find this number of moles we got now? So number of moles equals to 1 by 4. So now weight equals to, now number of moles, molar mass equals to weight into 4 into weight I can write now. So 4 into weight. What is the weight they have given? 4 into 4.25. So 5 4s like this you can do. 5 4s are 20, 0 2, 2 8 plus 2, 10, 0 1, 4 4s are 16, 17, 17.00. So which option is having 17 as molar mass? First option. You can take that as your answer. Hope it is clear. Right now, see, after writing NEET 2025 exam, if you are still sticking to very basic questions, that is not at all a useful one, because you have seen the quality of paper, how much depth they are asking, how much length they are asking. So you have to do some efficient quality questions only. Okay now? So first when you are starting, yes, you can start with very basic one, no issues, but you need to solve some few quality questions also. Do not stick only to the PYQs which came in the last 2024, 2023 only, which seems to be little easy, and do not blindly consider that paper will be again easy. Okay, you should be ready for the whatever the extent they are going to ask you. Whatever the difficulty level they are going to ask you, you need to face that with very confidence. Okay, so take this question as homework, okay, and tell me in the comment box. And you know, there is a question similar to this, I think this is the question, I think so, which is asked in the exam. It's a NEET previous year question only. So please write the question. Yeah. Then next, have you written this? Yeah. Let's move further. Now tell me, element A having molar mass 20 and element B having molar mass 30. Okay. Form a compound having molecular formula A2B2. Then what is its molar mass? Very simple and easy questions. Tell me for this. There are two elements A and B forming this molecule. Okay. So now element A is having 20 grams, element B is having 30 grams. So A2, B2 will be how much? Having how much weight? How many grams? Very easy. Very basic understanding is required. Should I tell or will be trying? See, more element A we have, its molar mass is how much? Okay, and B is having 30. So they are combining to form a molecule of A2, B2, right? Now, what is its molar mass now? How can we do? Yes, tell me. See, we have A, how many A atoms are there here? 2 into, for each A how much mass it is? 20. Plus B's are 2 and for each B 30. Okay, so this is 40 plus 60. So totally 100. Is that clear? Very easy now. So where we are facing difficulty, where we are struggling, that is what you need to point out. Then only you can able to improve yourself. Okay. Now, clear now that question? Okay. Now tell me, what about this one? Yeah. So here hydrocarbon is given, let us say CXHY is a hydrocarbon. So whatever the hydrocarbon it is, okay, having mass of 3 grams, this is the substrate. Upon combustion, it means we can treat with some oxygen combustion, it will give CO2 plus H2O, right? So no need to balance this equation here, just understand the question what they are asking. So this hydrocarbon combustion with how much grams of oxygen? 11.2 grams of oxygen produces 8.8 grams of CO2, okay, and 5.4 grams of 5.4 grams of H2O. This data illustrates the law of what? So which is correct here out of this? Data corresponding to which option it is? It means, see, just sum these two numbers, what we are getting? 14.2 grams and this side 12.16 plus 8, 14 point. So both side same mass is there, reactant side, product side, LHS, RHS are equal in mass. So what is that law expressing this? Conservation of mass, law of conservation of mass. So first option is correct. Simple now? Yeah. And then next, we will be discussing about percentage of composition in the next class, okay. So now I will be giving you few questions here, so just give a try for this, okay. So now, okay, let me conclude that number of moles completely whatever we discussed in the class, okay. So what we discussed, number of moles. So what is the symbol we are using? Number of moles indication N, okay. So number of moles if they give and they are asking weight of a substance, okay. So what they are asking, if the number of moles is given and they are asking amount of substance, that is what? Mass or weight, okay. If they are asking that by giving this, so what we can do? How can we find weight? Into molar mass or gram molecular weight we can say, okay. Now weight is given, number of moles is asked, what we can do? Weight divided by molar mass. Mm means molar mass, you can write. That will gives us number of moles. And one more thing, number of moles is given and they are asking us to find number of atoms. Number of atoms they are asking. What we can do? In number of moles is given and they are asking number of atoms. So we should multiply this with the Avogadro number and also with the atomicity. Atomicity indicates number of atoms in a given molecule. Okay. So now number of atoms is given and they are asking us to find divided by Avogadro number and atomicity. Okay. Now number of moles is given and they are asking volume of gas at STP. Gas at STP. Volume of gas occupied at STP. So how can we do this? We know number of moles is given. So 1 mole occupies 22.4 now. So n moles are given. N into 22.4 gives volume. So it means we should multiply with 22.4 liters at STP means. Okay. If volume of gas is given at STP, then how can we find number of moles? Huh? Yes, tell me. Divided by 22.4. That's it, 22.4 liters. Hope it is clear now? Huh. Now, they may give number of atoms, they may ask you weight. What is our center point? Always, whatever they are asking you. If they give number of atoms and they are asking you number of, what is the weight? So just convert into number of moles, then you can use this relation. If they give number of volume of gas at STP, then asking about number of moles, yes, you can use this, find this and go here, like that. Clear now? Everything is clear now? So by using this table, you can find anything from other given conversion. Okay. So now we will be asking you few questions based on this. Given 5.6 liters of methane gas at STP, then express its weight. Express weight of methane in grams and number of methane molecules present. Number of methane molecules present. This is a question, homework question. Okay, the basic question again. Based on this data only you can able to do this. Very easily you can do. Okay, and the next one more question I will be giving you. Homework question. Find number of oxygen atoms in 48 grams of ozone. Ozone formula is O3. Second question. Third question. Five moles of CO2 is given at STP. Then what is the weight of CO2? First question, then what is the weight of CO2? Very basic question. then first one is what is the weight of CO2, then next what is the volume of CO2 gas occupied. So these are the question. Even online students, yes. Who is this? Hi sir, Mahil Ki. Yes, Mahil. So you can try these questions. So what you are saying answer for which question? Mahil, just mention the question number or at least some question so that I can identify which one it is. Yes, 56, 5.6 by 22.4 gives number of moles, that is correct only. So whatever the formula you mentioned, it is correct only, Mahil. Yeah, so this is the second one. Then next, number of, what is the volume of gas occupied at STP, already I mentioned. Okay, then what we can do other than STP conditions means that is again we have different formula. So that there we need to use this ideal gas equation P1 V1 by T1 equals to P2 V2 by T2. So this is the formula we need to use, but not required here in the bridge course. We will do questions based on this in the upcoming sessions, in the daily sessions later on. Okay, so these things are at only STP you can do this. Okay, next total number of atoms. What I am asking total number of atoms. Remember this, total number of atoms present. Yeah, that's it. So these are the questions you need to answer. Okay, so homework question. So especially to the online students, I am giving you the question number, homework question this as question number 1, question number 2 and question number 3, and in that you have sub questions also. Okay, 3-1, 3-2, 3-4 like that you can answer based on the answer you are getting for the each question. So there is nothing to worry. Even if you give a wrong answer, there is no issue, you just give a try. So I will help you how to get the correct one also. Okay, so give your own response so that it will be help us to understand whether how much extent you are going to understand the given live sessions and all. Okay, so thanks for watching. If you have any doubts, you can ask me now. Can do this, I will check by the end of the day you have to do. Okay, then thank you, we will wind up the class.